So today's in this particular class, we will solve a problem where the diameter is not given. So if the diameter is not given, how to cope up with the problem, we will learn from this particular example. And by this problem, we have covered most of the problems on gears, as well as the spur gears, as well as helical gears. But I even do suggest that you have to solve the questions from the question paper, then only you'll get the broader idea. Okay, so most of the concepts will be very much same. 80 to 90% will be same. If at all you discover a new concept, please come up in the class. We'll discuss on that. Okay, so said that today will be the last class on the spur and helical gears. From tomorrow, we will be discussing about the worm gears. Okay, so we should go up with the given data. So helical cast steel gear with 30-degree helix. He says it is a cast steel gear. So one would be a pinion, right? From all the problems what you have solved, the small one we have taken as pinion, and the larger one we have taken as gear. So this is pinion, and this is gear. We have taken this as 1 and this as 2. Next, cast steel gear, he says. The material of this gear is, he says it as cast steel, just write it out, with 30-degree helix angle. So the value of beta, which is the helix angle, is given as 30 degrees, just write that. Next, has to transmit 35 kilowatt of power. So power is how much? It is 35 kilowatt of power, and the speed is given as 1500 rpm. Okay, if the gear has 24 teeth, so what I will do is I would take this as 1 and this as 2 as per the textbook. No issue if you take either of the things. Okay, so Z1, N1 is 1500 rpm, and similarly Z1 is how much? 24 teeth. That's great. Determine the necessary module. So the questions or the parameters which to be found or to find. Module is being questioned. Next, pitch diameter. So diameter is being questioned. So diameter is not given, but rather it is being questioned here. Next, and the face width. So even the B, the face width is being questioned. For 20-degree full depth teeth. So the teeth, whatever he says, it is 20-degree full depth teeth. He says very good. Next, the static stress for the cast steel may be taken as 56 megapascal. So I would take sigma d1 as how much? 56 megapascal as given in the problem. The width of the face may be taken as 3 times the normal of the pitch. Normal pitch. So width of the face in the sense it is capital B. He says it is 3 times the normal pitch. Normal pitch is indicated by PN. So this would be the major data for us. So it is in the given data. Okay. So the face width is 3 times the normal pitch, which is he specified. What would be the end thrust on the gear? So even he has asked us to calculate what is the end thrust on the gear. Very good. The tooth factor for 20-degree full depth involute gear may be taken as, even he has given this form factor thing. So you just take that. Form factor is given as 0.154 minus 0.912 divided by ZE, where ZE is equivalent number of teeth. So equivalent number of teeth, you can say, you can call it as formative number of teeth. Okay, there you can call it as virtual number of teeth. You have many definitions for it. So this is the problem. So I have just collected the data. which all was there in the problem statement. Okay, now, so what is your first step in the problem? It's to identify the weaker part. So now identify the weaker part. Since both the materials are made up with same material, pinion would be the weaker. Just take that. Virtual number of teeth you just calculate. Okay. First of all, in this particular problem, if you observe, he has not even bothered about the pinion. He is just asking us with respect to only one gear. Okay. So no velocity ratio, nothing. So he's just asking us to calculate the parameters which are confined to only one gear. So we'll just move on like that only. Okay. Now, virtual number of teeth you just calculate. You know the value of Z there. Just calculate it's 24 number of teeth on that particular gear. So cos cube beta value is given as 30 degrees. So what is the virtual number of teeth? $36.95. So 36.95. So I would take it as 37. Next. Now you have to find the module. All of you open your data handbook and open this particular formula 12.24b, which is at the page number 214. Okay. So if you observe this particular formula, I have just taken a screenshot of that particular formula 12.24. If you go there, you have two formulas as indicated here to calculate your module. This is the first one which you are using it regularly till now to calculate your module, isn't it? So this can be used only when the diameter is known. Okay. If the diameter is unknown, what you have to do is you have to immediately shift to the next formula. Okay, so this particular formula you have to use when the diameter is unknown. You can just take a screenshot of this so that it would be helpful you to write the notes accordingly. Okay. So just in your data handbook itself, you can just write with your pencil. This has to be used when the diameter is known, and the second one has to be used when the diameter is unknown. Now, since in this particular problem, the diameter is unknown, what you have to take? You have to take the second one, which I have done there, take that particular thing. Mn is equals to cube root of 2 times of MTCW cos beta divided by sigma d CV k y z. So many parameters are there. We will just calculate one by one. If it is not available, we will assume a suitable value. So that is all we have done till now. First one, you have to calculate MT. So for that, P is equals to 2.d by 60, right? So N1 you know, P you know. So give me the value of MT, which is torque. Whatever the answer you get, it will be in Newton meters. Later you have to convert it into Newton mm. Newton mm. Okay. What is the value of MT? The torque. Can you give me the value? 222.81. So 222.81 in Newton meters. If I want to write in Newton mm, it is same thing, but I have to add into 10 to the power of 3 over that, right? Very good, very good. So in Newton m. Now, you know that K is equals to B by M or B by Mn. So here it is clearly mentioned that B is equals to 3 times of Pn, which is given in the problem that I have taken. Just substitute back in there here. In the place of B, substitute 3 times of Pn. Now, all of you go to equation number 12.19a, where it says Pn is equals to pi m cos beta. It is in page number 211. Okay. And even Mn is equals to what? Even Mn is equals to m into cos beta. So what I'll be doing is I'll be substituting the value of Pn. I'll be substituting the value of Mn now. So Pn I have taken from 12.19. Mn I have taken from 12.19 A and C respectively. Okay, where Pn is pi m cos beta, Mn is m cos beta. So same thing, I am just taking it out. Now when I substitute Pn and Mn as pi m cos beta and m cos beta, what happens? M goes away, cos beta goes away. So the only remaining is the 3 pi, which I have taken here. So the value of K, this is the way I would obtain the value of K, which is 3.5. Just take this. Now, since the value of velocity, since you don't know the diameter, you cannot calculate V. So if you want to calculate the value of CV, no, you require velocity. For velocity, it is pi dn by 60. You don't know this particular diameter. So you cannot calculate velocity. So you cannot calculate CV. Thereby, you have to assume it as 0.5. So assume CV as 0.5 and CW as 1.15. Okay, let's move on. Why he has been given the expression there, Lewis form factor, which says it is 0.154 minus 0.912 divided by ZE1. So ZE1 value is how much? I'll just see it. It is 37. So just take it as 37. Give me the value of capital Y. Oh, 0.406. 0.406. Yes. Now substitute everything in the value of in the expression and give me the value of Mn. This is the only change in this particular problem, guys. Nothing. Everything is same. Only the way you calculate the module and the diameter is not given, a little bit a different process. That's it. Rest all, it is again same ditto copy, all the problems. 5.56 standardized value. Give me the standardized value of that. 5.56 mm. Now go to table number 12.2, everyone. In the page number 229. Give me the standard value, preferably in the first column. 6. Okay, so then show them a 6. So 6 mm is the standard value. Okay, okay. Now, as soon as you get that module, first thing what you have to do is, in this particular problem, the diameter is not given, no. So go for the equation number 12.19 E, which is in the page number 211. There it is being mentioned that D is equals to M into Z divided by cos beta. That formula you can find it there. In page number 211, equation number 12.19 C. Pick that particular equation over there. Okay. So from that, just now we have finalized the value of Mn, substitute it. This it is required to check. Before checking the Mn, I'm substituting. I know that, but it is required for the proper check. So that's why I'm calculating it now. Okay. So Mn value have finalized to be 6 mm. Z1 was 24 there, and beta value was 30. So what is the value of PCD? Okay, 166.27. I would take that. Can I just round it up to 167 mm? 167 mm. Next, go for the face width calculation. In the question, he has neatly mentioned that face width is 3 times of your normal pitch, and normal pitch is 5 times of your normal module. So just substitute that. 3 pi into normal module is 6. So this is 18 pi. 18 pi value is how much? $56.54. Then I will take it as 57. I will take it as 57. Next, as soon as you calculate the B value, you have to check for B. For that, you can use the previous expression which you have used already from the page number 213, equation number 12.23b, where it says B minimum is equal to 1.15 pi times of Mn divided by sine beta. This is not something like this. It is, oh shit, this is sine beta. Just replace the things up. It is sine of beta. Just substitute and calculate the B minimum value. That is the minimum face width which has to be there, and whatever your calculated value is there, that should be greater than this particular B minimum, 43. So I think now it is fine, right? So B minimum was supposed to be 43.55, but your calculated value was 57. So it is above the B minimum value. So you can write the sentence there, since B is greater than B minimum, the calculated value of B is safe. Just write that and go for the checking of sigma D. Just go for the checking of sigma D. Again, you can use the equation 12.24a in the page number 214, where V is given by pi d1. Just you have calculated, I have substituted the same thing. N1 is 1500 divided by 60. Give me the value of V. Based on the value of V, we are going to select the formula for the CV in the page number 214. .19 is the velocity value, 30.19. So based on this velocity, So it comes in between 10 to 20. Okay, pick up that particular formula, 15.25 divided by 15.25 plus V. Substitute the value of V which you have just calculated, which is 13.19, and give me the value of CV. .536. Okay, 0.536 is the value. Now, next, go on with the calculation of FT, which says it is 2 times of MT divided by D. So D is 168, which you have calculated, and the MT value is 222.82 into 10 to the power of 3 in Newton mm. So that's what I have substituted. From that, you can get the value of FT as 2652.62. So this is a textbook value. Please check on that. I never ever trust the textbooks. There are many mistakes even in JPK Das, even in Raghavendra. There are many mistakes. Just check this particular value. Correct? 2656.61 now. Okay, I would take that. It is 2656 point. Correct it, 2652.61. Now, substitute all these in that expression. Only sigma D would be unknown there. Calculate that particular value of sigma D and make sure it is less than 56. If it is less than 56, you are safe, or else you have to increase your module once again and do all the calculation once again. So check whether it is less than 56 or not. Ritvik S. Shetty. Ritvik S. Shetty. Okay, 40.9. So 40.9 in the sense it is less than 56. So just write the statement which is most satisfying for me. As I told you in the last class, writing these statements are most satisfying. So whenever you solve a couple of problems, you will find the essence of that particular satisfaction when you write this. Since the calculated values are less than the permissible values, the assumed values are satisfactory. Just write it and leave it there. The assumed values are satisfactory. Okay. Now, in order to calculate the axial stress, you have this particular formula. Just check whether it is available in the data handbook. FA is equals to FT times of tan beta. Is it available in the data handbook? Just check. Well, I would check here. FT, what is that expression? Axial thrust. So it definitely come in helical gears. So under the helical gear, start to. So already I have moved to worm, bevel, helical. Okay, helical in the start agadu. Here it is. So the axial thrust, it is given as FA is equals to FT into tan beta. Okay, 12.21. Page number is to 211. 12.21, page number 211. So it is 12.11 in the page number 211. So there you can find this particular expression. Use that, okay, to calculate the value of the axial stress. What is the value? Good. For us, very good. 40.93. Vikshit. Ritwik ST. I called him many times. Okay, 1531 something. Okay, I take that value 1531.49 newtons. So this particular value was the value of axial stress. So once you calculated the value, so I think every part is being calculated. Now, so there ends your module number 2. Okay, so module number 2 consists of the spur gears as well as the helical gears. So definitely one question would come from the spur and the other from the helical. Do not take the chance, because do not select the spur gear and leave the helical gear. Please do not do that. Why? Because the only lifesavers for you are the gears. So at most cover all the 4 gears. Why? Because in the other modules we are just reading just half of it. When it comes for module number 1, you are reading it only belts, you are leaving springs over there. In the module number 5, you are reading anti-friction bearings and you are leaving the other part. Similarly, in the module number 4, you are discussing only clutches but not reading the brakes over there. So like that, we have already taken up chances in the module number 1, module number 4 and module number 5. Please do not take a chance in module number 2 and module number 3, which are gears. So read all the 4 gears. If you just read the gears, it is enough to pass. It doesn't mean that you have to read only gears. Just read the gears. It will be definitely a supportive thing in your examination. Said that. So please read this particular thing. Anyone? Nandan, can you read it? Nandan? Not that. Srinidhi?
Yes, sir.
ಓದು ಇದನ್ನು.
Yes, sir. Sir?
Read it.
Hello. Can you hear me, sir?
Nandan. ನೀನೇ ಓದು ನಂದನ್. Read it.
Dear all, only solved problems in class or notes are not sufficient. You must solve all the previous year question paper
Hello,
compulsory.
sir.
Okay. Job is done, Nandan. So
Only
Muhammad
solved
Amir has
problems in
helped
class
me.
or notes are.
Okay. Carry on, Nandan. ಓದಪ್ಪ. ಕಂಟಿನ್ಯೂ ಮಾಡು. ಲೋ ಇದ್ದಾನೆ, ನಾನು ಹೇಳಿದ ಒಂದು 2 minutes ಆದ್ಮೇಲೆ ಕೇಳತ್ತ ಅವನಿಗೆ ಪಾಪ. Okay, fine. Understood? So we have solved many problems in the class. All are easy. Even if you go for question papers also, the problems are easy over there. It seems you can do it. But please do practice it. Okay? So any changes required, the way it was dealt in the module number 2, which is our first module, no? We have just started with the module number 2. That's why I'm asking at the end of the module number. Any changes required in the way it was dealt. So that would be implementing from the next module. So if at all you require any changes, whether the speed is more, the speed is less, the way it was dealt, anything want to be changed, you can just insist now. Okay. Okay then.
Hello, sir. Sir,
ರಿತ್ವಿಕ್ ಎಲ್ಲಿ ಹೋಗಿದ್ದೆ ನಾನು ನಿಂಗೆ ಕರಿತಾನೆ ಇದ್ದೀನಿ ಆಗಿಂದ.
ಸರ್ ನಾನು ಇದು ಮಳೆ ಬರ್ತಿದೆ, ಸಿಗ್ನಲ್ ಇಲ್ಲ ಸರ್, ಎಕ್ಸಿಟ್ ಆಗ್ತಾ ಇದೆ ಗ್ರೂಪ್ ಇಂದ.
ತೊಂದರೆ ಇಲ್ಲ. ಸೊ ನೋಟ್ಸ್ ಎಲ್ಲ ಬರ್ದಿದ್ಯಾ?
ನೋಟ್ಸ್ ಇವತ್ತಿನ ಬರ್ದಿಲ್ಲ.
ಇವತ್ತಿನ ಬರ್ದಿಲ್ಲ, ಬೇರೆದೆಲ್ಲ ಬರ್ದಿದ್ಯಾ?
ಹಾ.
Okay. Now I would share this particular thing with you, the module number 1 notes. So do not depend on my notes. Okay. So you have to write your notes. That is very important. Okay. So ಪ್ರತಿಯೊಂದು ಮಾಡ್ಯೂಲ್ ಆದ್ಮೇಲೆ ಜಸ್ಟ್ ಲಿಸ್ಟ್ ಔಟ್ ಮಾಡ್ರಿ ಲಾಸ್ಟ್ ಅಲ್ಲಿ ಯಾವ ಅಸಂಪ್ಷನ್ಸ್ ಮಾಡಿದ್ದೇವೆ, ಏನೇನ್ ಕೊಟ್ಟಿಲ್ಲ ಅಂತಂದ್ರೆ ನಾವು ಏನೇನ್ ತಗೊಂಡಿದ್ದೇವೆ. ದಿಸ್ ಇಸ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಟು ಬಿ ಲರ್ನ್ಡ್. ಓಕೆ, ಎಲ್ಲಿದೆಪ್ಪ ಅದು? ಮಾಡ್ಯೂಲ್ 2 ನೋಟ್ಸ್, ಎಕ್ಸ್ಪೋರ್ಟ್ PDF. Okay, so you guys can mark your attendance in the same Google Sheet and you can leave. So I will be leaving 20 minutes before today. Okay, enjoy.
Sir, what about the assignment, sir?
Assignment, I will tell you. I have planned a different story for that. So for that, I will tell you. Don't worry about the assignment as of now. Okay.
Okay. So